Hello everyone and welcome to today's SPaT Challenge webinar, Deployment and Validation. My name is Neelu Parvinashtiani and I will facilitate today's webinar. Today's webinar is hosted by the National Operations Center of Excellence, or NOCO. If you don't know already, the NOCO offers a variety of resources to support the transportation systems management and operations community. We have a few ways for you to connect to us. So if you look at the useful links box at the bottom left side of your screen, you can see direct links to NOCO Knowledge Center, when you can find several resources that are available for you to access and gain some knowledge about TISMO. Also, we have a YouTube channel where you can find out different webinar recordings and other videos that we have. In addition, we have our Twitter account, so follow us on there and see what's going on in the TISMO community. You can also directly download today's slides from Download Slides resources. This is available to you at the beginning, where I'm doing now the intro, and also at the end during Q&A. Also, check out the first two upcoming webinars that are available here. So if you click on those links, you are directed to those webinar pages. So I'll cover a few logistics before I go through with the agenda on our speakers today. For this and every webinar, we will be recording the webinar, and that is available to you along with the presentation slides through the on-demand section of on-demand learning section of our website. A follow-up email will be sent to you when that recording is available, so you know you can go and view it. We will have a question and answer session at the end of the webinar. So please, if you have any questions, we encourage you to put them in the question discussion pod here on the bottom of your screen. So the questions will be read out loud one at a time, and our presenters will answer each question during Q&A, and also if possible, they will answer it in the chat box for you. So with that, I'll now quickly go over the agenda and the presenters. I have asked the speakers to briefly introduce themselves before their presentation. The presenters' full bios are available in NOCO webpage, so please refer to those to learn more about our speakers today. So today, first we have Blaine Leonard, who will go over an introduction in the beginning. And next we will cover the security credential management by Steve Novosad from HNTB. Our next presenter is Jay Perick, who will cover verifying SPaT deployments compatibility with vehicles. And after that, we will have Joe Gorman to talk about the examples of a completed SPaT deployment verification. And our final speaker today is Chris Stanley, who will talk about the US DOT CAV support services. And like I said, at the end, we will have the Q&A session where we will have all our panelists to help answer your questions. It would be helpful if you mention who you are asking the question from, so if it's for a specific person or it's for the whole group. And also in this webinar, we will have a quick poll before Q&A to ask you what are topics that you would like to see as resources or webinars that are directed to SPaT Challenge. So we will cover that before the Q&A. And that is all I had for the agenda and my intro. And with that, I'll hand it over to Blaine to start us off with the webinar. Blaine.
Thank you, Nilo, and welcome to everyone on the webinar today. We appreciate all of you taking some time to learn more about the SPaT Challenge as we try to share everyone's experience and lessons learned here. I'm Blaine Leonard with the Utah DOT. I'm also the co-chair of the AASHTO Connected Automated Vehicle Committee, and involved in some other things at the V2I Deployment Coalition. So there's a lot going on. Some of us were at the ITS America conference last week, and if you were, you saw that there's a huge amount of excitement about connected and automated vehicles in a broad variety of ways, and the SPaT Challenge was talked about quite a bit. So there's a lot happening, and we hope to be able to share some of that. There are about 100 of us on the call today, and so we appreciate all of you being here and hope this is useful. Those of you who've been on these calls will sort of know the next couple of minutes. The SPaT Challenge, of course, is a challenge that's been issued to all of us in the state and local public sector transportation arena to deploy DSRC infrastructure to broadcast SPaT and MAP in at least one corridor or network of about 20 intersections in each state by the first part of 2020. So 20 intersections in 50 states by 2020. We have been doing this for a little over 2 years now, and we've had a lot of progress. There are now, according to the map, at least 35 locations that have committed to the SPaT Challenge in 25 states. We know of 2 or 3 other places that aren't on the map yet. We're just trying to get some of you to fess up and provide some information. This indicates that there's about 500 roadside units operating in those blue pin sites that have completed their deployments, with at least another 2,300 planned in these sites. There are non-SPaT Challenge sites as well, test beds and other things that have many other RSUs. This is just sort of the tracking of the SPaT Challenge. Today's webinar is the 6th in our series. We originally planned for 5, frankly. We added 1, and now, as I'll talk in a minute or 2, we're going to add a couple more. There's been a lot of interest in these. The first one was an overview of the SPaT Challenge in March, and we talked about the concept of operations and requirements documents and a little bit about cost procurements and corridor selection. The second one was focused really on the SPaT messages, and the third one on map messages. And the fourth one was one we added where the folks from the Leidos Saxton Lab at Turner Fairbanks Highway Research Facility demonstrated a map creator tool that some of you have used. The fifth one was really about design considerations, specifications for the RSU, roadside equipment, backhaul communications, and licensing. And so those, as Nilo mentioned, are all archived, and you can get to them. On the resources page of the SPaT Challenge website on the National Operations Center of Excellence, you can find all this information. You will notice in this visual that the National Operations Center has done some upgrading of their site. It's got a little bit different look and feel. Our resources are still there. You can download the verification document, which Jay Parikh will talk about today, on this site, the blue arrow near the bottom, and you can see these webinars and the recordings of these webinars in the bottom arrow there where you go in to register as well. If you are deploying and aren't on the map, here's the link to tell us that you're doing that. We would certainly like to hear from you. And here, of course, is the list of all the resources on that page, a few of which are still in process. Our next webinar after today will be on July 17th, and what we've added here is a presentation on some operational deployments, people who have already deployed. We found from some questions in the last couple of webinars that there's a lot of interest in talking to people who've accomplished a deployment, a lot of lessons learned there, and so we've added this webinar in July to talk about that. And then there will be another one in August, and I think Nilo has the date for that later on. There's one in August which will talk about sort of next steps, the fleet challenge and a few other things. So stay tuned for all of those. Let's see. We've got so I'd like to turn the time over now. Thanks again for all of you who are here, to Steve Novosad from HNTB to talk about the security credential management system and some related topics. Steve?
Thank you, Blaine. Hi, everybody. I'm Steve Novosad from HNTB. I'm Associate Vice President here. but more importantly, I am the technical system lead for the PIA Tampa pilot that's going on here in the Tampa area. We're one of the 3 pilots that are doing the V2I piloting for US DOT. The other 2, as you probably know, are New York and Wyoming. So today what I was going to talk to you a little bit about is SCMS and why it's important and why we need to get going. So our topics are going to be, as you can see, we'll talk about kind of what the purpose of an SCMS is, what we would like to see an SCMS do, but maybe where reality is going to become, how does an SCMS function, why does SPaT need SCMS. We'll talk about application certificates and enrollment certificates. We'll talk about some limitations, and then finally we'll wrap it up with some protection and some earlier deployer ideas. So what is the purpose of an SCMS? Well, as probably everybody knows, the real purpose is to establish security and trust as we broadcast these messages over the air. We want to ensure that a message that our devices are receiving are coming from a trusted source. And so the fact that we can receive that message and recognize that it comes from a trusted source, we can be confident in that we can use that message, decrypt it, and use it for whatever purposes we're looking at. The fact that the certificates timeout allows us to be able to not have to worry about credentials being tracked, because over time each of the certificates will time out, and you'll have to get a new batch of certificates. And really PII, in our world, there really is no PII per se, but if there is a vulnerability of some sort, it would be that somebody like a third party would somehow be able to correlate things. But the way that the system is set up with SCMS, as well as the security, as well as the way the messaging is set up, there's really no opportunity for PII to be compromised. So what would we like an SCMS to look like? And this is, we would like it to be simple, right? So what we would like is to one of our devices say, hey, I need to get enrolled. So it contacts the provider and asks for an enrollment certificate. Once they go through the process of verifying that the device has been certified to their satisfaction and meets all the requirements, then they would be able to contact the root certificate authority and receive an enrollment certificate. Once the device receives that enrollment certificate, then what would eventually happen is the device would need application search, and we're going to talk more about this later, but the application search would then come straight down from the root CA through the intermediate pseudonym, the location obscure proxy, and then into the devices. And then off on the side, any misbehavior that was detected by the system would be identified and would be also pushed down through that same mechanism to the devices, so that we would know who the bad actors are in the environment. The reality is probably going to be somewhat way more complicated. There's going to have to be policy established at some level about how SCMS is going to operate. Will we have a single root approach? Will we have a multi-root approach? And even in a single root approach, as you get more and more complex, you can see the idea is that the different devices will have different types of interfaces. Everybody will still have to enroll. Everybody will still have to get application certification. Misbehavior detection is probably not going to be very straightforward, because trying to figure that out and get that information back and verify that, yeah, these are misbehaving devices, and taking their certificates and invalidating them is going to be a real challenge for everybody. So much more complex in doing this. I think we're at the infancy stage right now. The pilots themselves are implementing SCMS as we speak. Here in Tampa, we're using a commercial provider to do that work, and we are downloading certificates actually at the manufacturing facility for our onboard units, and then we are pushing that, installing those in vehicles, and our RSUs have all been provisioned and all have certificates, and are operating in the signed environment. So we are doing testing and some live testing of our stuff here with the certificates, and it's working pretty well. So SCMS guarantees trust, and that's really what this means. It doesn't guarantee that your data that you receive is going to be valid, but it does guarantee the fact that the message came from a trusted source and that you can decrypt the message and use it safely. It will not protect your infrastructure. This is not like a firewall as such. These are just certificates that are signed to each message as it's sent and received, and then encrypted and decrypted. And you really don't want to have an SCMS if you have insecure infrastructure. If you have the ability, if there's a lot of vulnerabilities in your network or in your infrastructure, that presents opportunities for people to hack in and bad actors to be established and to do some things that we don't want to see happen. So if you do SPaT without SCMS, what's the implications of that? Well, if there are applications out there, and there are now, people are deploying onboard units. I know there's a few places around the country that have RSUs that simply are just listening, and they're seeing 100 or so onboard units come by their RSU every week. So there's people out there doing things with the technology that we really that aren't telling anybody. And so if you're not securing your messages, then you're not going to be trusted. So your SPaT message would be ignored, your map message would be ignored, and if you're doing anything with transit signal priority, your signal status message would be ignored. And if you don't start in the beginning with security, making sure that you've got your privacy well preserved is going to be more and more challenging as you're trying to retrofit essentially your security on your messaging after you've rolled it all out. On the flip side of that, RSUs will be able to receive any signed messages, like a basic safety message or a signal request message. However, they won't be able to do anything with them, or I take that back. They could do something with them, but they won't know if they're from a trusted source. So if you have any apps on your RSU that's actually trying to do something other than just broadcasting out SPaT and map, you really need to have your security in place so that you can decrypt the messages and know that this is coming from a secure and trusted device. So let's talk about in a little more detail where the application certificates come from. So first off, you have to have what I'm calling a certified RSU. In today's environment, what that means, when you talk to most any SCMS provider, will tell you that the device needs to be Omni-Air certified. And so once you have your device or the device is certified by Omni-Air or other entities that might exist down the road, then you can actually go and request your enrollment certificate from your SCMS provider. Once you get that, you have to, every device, RSU, OBU, has to have a hardware security module, and those certificates are stored in there. And that's where they're kept under lock and key safely so that no one can access them. Once you receive your enrollment certificate, it's also associated with what we're calling PSIDs, or Provider Service Identifier. And you may have one or more of these depending on how many applications you have, because each of the connected vehicle applications are actually grouped together and categorized according to PSIDs, so they can be identified. PSID identifies the type of applications that you might be going to use. And then, so that's how now you're enrolled. Now what you need to do is you need to actually get application certificates. So what happens then is the RSU makes a connection with the SCMS, typically through IBP6. I know many of us don't have IBP6, so what we end up doing is creating a tunnel through IBP4 to be able to connect to the SCMS. You let them know, you identify yourself with your enrollment certificate, and then the SCMS will send you application certificates. And somewhere along the way you've decided how many of those you want. Do you want a week's worth? Do you want a year's worth? Do you want a month's worth? And how often you're going to refresh all of that. So those are stored, and I apologize, this should be just one bullet, but the application certificates are stored in the hardware security module, just like the enrollment certificate is. And again, these things have to be refreshed periodically because either they're too old or you're using them all and you need to request more. So what about RSUs that may not be connected all the time to your network or don't want to connect all the time to the SCMS? What do you do? And so there's some thinking that has to go on and about how you want to do this, but most importantly, you could do this by creating an environment in your traffic management center or in some place like that where you can have an appliance essentially that is allowed to exist in there. It must have a hardware security module, and you must have the right conditions set up so that you can do this. And then what happens is this device in your traffic management center would do the enrollment, and it would request the certificates and hold them all inside its hardware security module inside the traffic management center. And then when an RSU actually needs to get a certificate to, for example, broadcast SPaT or broadcast a traveler information message, it would request a certificate from the device, and then the RSU would sign that message and send it out. The advantage of that is all your certificates are in one place. You don't have them spread out all over your RSU network. Disadvantage is you have to always come and request the certificate, and if you have a problem with communication or something, you might have an issue there. So it's just one of those things that you have to look at. I know, for example, the New York pilot is doing it this way, where they're having an appliance inside their TMC, so that might be something if you're interested in to talk with them about. The Tampa folks, we're doing it the other way. We're putting all our certificates out on the RSU. So what are some of the limitations of SCMS? And you've heard me say this multiple times already, but just to reiterate it, it guarantees trust in the source of the message. So it guarantees that who is sending the message is a trusted source, and you can rely on that. But it again does not guarantee the contents of the message to be valid. That has to be done by the application once it gets the message and working on it. Again, we've talked about this, but enrollment certificates can only be obtained by certified devices, and again, certified by approved certification labs. And as I said, right now, OmniAir is the entity that does that. OmniAir has three certification labs now that you could send your devices to have them certified. It doesn't protect your infrastructure. This isn't a firewall or anything like that. These are certificates that are signed and sent with the message, just like you would do through your internet browser when you're doing secure transactions, for example, making a payment or something like that. And then the hardware security module is really not I hear we call it, it's not your do-it-yourself, or it's not an off-the-shelf solution. This is a very complex thing, and right now the requirement is to be FIPS Level 2 certified, and I wouldn't be surprised if they actually went to FIPS Level 3, because they just add this, because what's held inside that module is all the information about the certificates, and if that gets out, then there's a potential for obviously some bad things to happen. So how do we protect RSU data? Well, you have to know how your RSU is communicating with your signal controller. Is it over the Ethernet connection, serial connection, however that works? You need to know how you're communicating with your traffic management center, and then what information are you actually providing between the two sources. And so, do you encrypt data from, for example, from the RSU to the traffic management center, so that in case somebody, if you're going wirelessly, for example, tries to hack into that and steal it, or you just have to make business decisions about that. Of course, the more secure it becomes, the more overhead you have, and the more bandwidth it takes. So if you're fiber connected, that's one thing. If you're wireless connected, that's another. how can you keep unauthorized network traffic from, how can you detect and block unauthorized network traffic? That's something you just need to think about. We'll see on the next slide a couple of suggestions for that. And then how can software tampering be prevented, detected, restored? You've got to think about those kind of things. Can everybody has the number 6 key to the signal cabinet. We all joke about that, but the reality is that your cabinet needs to be secure so that people can't get into there and get to the signal controller or the RSU or any of the devices. So protecting the networks, one way would be to have a separate network for the SCMS and then one for everything else. You want to monitor all your data on the SCMS network just to make sure that there's there's nothing going on, there's nothing funny business happening or anything like that. Of course, we definitely want to make use of virtual private networks to help secure and put the devices all in one network where they can only communicate. And then you have to assume that your field cabinet is going to get compromised. And so you want to make sure that you don't have any open ports out there that people could plug into. You want to have make tamper-proof covers for the ports, or be able to know when someone's getting in your cabinet. For example, the door switch would activate an alarm back at the TMC. And then really, you need to get with your field technicians, because they're the ones that are going to be the ones going out there and looking at the equipment and opening the doors and trying to figure out what happened. They're really your first responders, so they need to be educated. They need to know what's happening, and they really need to be so they can take care of anything that they need to when they get there. And finally, let's just talk about some things that I think are important from an early adopter perspective. One is be aware of the risk, and what do I mean by that? Well, here I'm saying the risk of setting up your SPaT challenge without security versus setting it up with security. How much are you really risking there? Is it worth that time to do that, or is it time to go ahead and consider, let's get our security in place? Reach out to the other SPaT challenge sites, see what they're doing, and of course reach out to the 3CV pilots. We all have experience now with SCMS and stuff, and I think we'll all be happy to share our thoughts with that. And then, start talking to these commercial vendors that are out there to see what they have to offer and ideas that they have. They're all very willing to come and sit down and have some discussions with you, because they're all looking to sell their product to you. So they'd be happy to do that. And then finally, I think, in my opinion, that you should be doing SCMS now rather than later. Because if you wait, the challenges of having to do that could become onerous in terms of you're going to have to set up secure pipes for your RSUs to be able to communicate with the SCMS. You might even have to take them down and take them into a secure location, depending on the networks that you've got set up. So think about what you have now and how you could easily set that up. So. And with that, I'm going to turn it over to Jay Parikh, who's with CAMP.
Thank you, Steve. Good afternoon, everyone. This is Jay Parikh from CAMP. CAMP is a research arm of OEMs working together on a pre-competitive area in the particularly vehicle-to-vehicle and vehicle-to-infrastructure communications, and in collaboration with and cooperative agreement with the Federal Highway. So moving forward, what I'll talk about today is, you heard Steve talk about the message encryption and authenticity of the message, but that SCMS does not provide you verification of the data or the content in the message. So I'm going to talk about the content part of the message and how to verify that in this project. So to this end, CAMP has developed a document called SPaT map verification, and I'll go over this content of this document. Just to start with, this project is in a cooperative agreement with federal highway as a part of the disclaimer. And all the findings or the work that we've been presenting here is of CAMP opinions and the output of the CAMP's work and not from the US DOT. A consortia at CAMP called Vehicle to Infrastructure Consortia, consisting of 9 OEMs, and so this project was conducted under the auspices of those 9 members. What I'll go over today is what the red light violation application means and what the system architecture. The verification process that we have developed for targeting the red light violation warning from the OEM's perspective, because you can be transmitting information that's been specified within the SAE standards, but we realize that some of this information is optional. However, the application requires more than what's been defined within that optional requirements or optional data elements. So I will go over that also. So this is again from the point of view of having it from the red light violation application. We talk about system architecture briefly, what has been put together from the vehicle side of it as well as from the RSU side of it during our testing and such. What are the intersection implementation requirements, and followed by that intersection implementation verification steps, goals, objectives, method level and application level, and finally the structure of the document that defines how it's been laid out. Okay. So with that, it's just an overview of what the red light violation warning application does. It warns the driver of an equipped vehicle approaching a signalized intersection when a potential of running a red light violation. So when that potential exists, this is what the application is warning the driver of red light violation. And it requires specific pieces of information coming from RSU, which is of course the SPaT information and map information, and optionally but recommended GPS RTCM correction information. The application level is on a lane-based information, meaning that vehicle needs to understand what lane it is on and associate the correct information with the lane and the phase to generate a threat for a red light violation warning. So this is just an architecture overview of how things are connected together in terms of the RSU and information that needs to be received by the vehicle, and how the vehicle is processing that information. That also includes the interface with the CAN bus, so that it has vehicle dynamics information along with it for the threat assessment. So to start with, what are the requirements in terms from the infrastructure side of it? So of course the RSU specification includes US DOT DSRC specification document 4.1, which is I think in the progress of also going to 4.2. Message specification as per the SPaT and map message J2735 2016 version of the standards. And you already heard Steve talk about SCMS and other requirements for the security purpose. So after you implement this RSU at an intersection, what are the things that we need to address or understand for verification purpose? So one is to correct, to make sure the operation is correct and needs to be verified, and compliance with the specifications, and also accuracy of the data element, which is very important element here. If that has been verified, then it can be utilized nationwide, primarily because the application that runs on the vehicle side of it can be anywhere nationwide, and they would like to have, meaning the OEM would like to have all those information transmitted is compatible for the application that's been deployed by the OEMs. The document addresses those in a 3 different levels. One is the system level, which is comprising of the systemic requirements such as the standards for RSU and message and other things, SCMS and such. The second level of verification is at message level to confirm that the message transmitted is as per the standards, and content is also as per the standard. And third, which is very important element, though it is considered as optional, but from the receiver point of view, which is application level, to make sure that data element and the content of the data element are correct, so the application behaves as intended. So the objective here is to develop this pattern map process to help deployers and deployment activities, that's initiatives through the SPaT challenge. So that's where the document was put together. The scope is to intersection. So using the steps and process, we can identify the application, identify or at least go through the process to see if the intersection is transmitting as per the defined requirements. And the outcome will be to validate a process. So this is what we have developed as part of this exercise. And we've been doing this testing along with Michigan DOT, and what we learned through our process, we defined the document. So the version of the document that is out today is version 1.2, which is from the NOCO's website that you can download. So the document comprises of 5 major elements, which is the V2I applications and system architecture, minimum performance requirement from the application's point of view, which is a SPaT map and a message transmission requirements, followed by verification of an installation, which is a system level, message level, and application level, validation of and the steps that we went through and what we discovered during the process when we did verification of several intersections, and what we discovered out of that in our observations. And last but not least, here we are added is also based on the conversation we are having with the IOOs regarding what are the needs for RTCM or GPS correction, and that section talks about the needs and requirements for RTCM corrections for the transmission part of message also. So this is quickly go over the OBU. What we have is an OBU that receives DSRC message and a GPS receiver, including the GPS receiver, and has an HMI DVI that allows us to see how the application is behaving, what message information is received, how the signal phase information is associated with a specific lane information and so forth. And RSU, of course, that's US DOT, DSRC, RSU standards, and signal controller 1202 standards. And optionally, we would like to also receive RTCM or GPS correction information along with it. So the message transmission requirements talk about what rate the message needs to be transmitted. So MAP is transmitted at 1 Hertz and the SPaT at 10 Hertz, and of course RTCM 1001 and 1005, they are at 2 Hertz and 5 Hertz. That's what the requirements. The document outlines additionally talks about the required versus optional message, and I'll show you from the application point of view what are the message requirements that needs to be transmitted, or data elements needs to be transmitted, because the J2735 may have identified some of the data elements as optional. However, they are important elements for the application's point of view. The other important part that we learned through this exercise is also the interpretation of the data elements and their use. There has been a scenario where it has been interpreted incorrectly at some of the intersections, and that was identified for the application's requirements point of view. Timing requirements is also accuracy is very important. What we learned over the period of time during our exercise and testing is that the RSU needs to be synchronized GPS time, because that timing is very important for the OBU synchronization for the OBU timing, so the time remaining for the next phase is consistent and correct information coming out from the RSU that is received by the vehicle. And mapping accuracy requirements also part of this document that we have listed in this requirement part. So from a system level requirement, the reason for having system level requirement is to ensure that system is built according to the standards defined by US DOT, RSU specs, NTCRP, and SCMS requirement. Now the document does not go into detail about this because there are links that provide you the detail for those specifications. The message level requirement ensures the message transmitted by RSU are as per the J2735 2016 version of it. That's what we have been addressing, and that's what we've been using it in here. And the proper encoding in the UPER encoding is done, and data elements are formatted according to that requirement. We have learned and experienced that in some messages that we received during our testing, they were in 2016 version of it, but some of the data elements were still being transmitted in 2015 version of the format. So those inconsistencies was observed in some of our testing also. And of course, the data content is validated for correctness and its accuracy. The application level then provides you a more detailed information about the transmitted information is correct or not. For example, a lane that indicating that it's red, is that exactly what the SPaT is telling us at a given time? And also the time remaining for the next phase is also indicated correctly, and at the same instance, the signal light controller is also changing the phase information. So these are the verifications are very important for the application to behave correctly. So this diagram talks about what are the steps that one needs to go through in order for the verification part of it. And again, you start out with defining the map of an intersection, which can be done either manually or automatically as step number one, and provide the information, the valid information about the reference point, the number of lanes, node points, and so forth, which are valid information and correct information for that specific intersection that for the map that you are transmitting. Today, there are no specific standards defined how that information is loaded into an RSU. Depending upon a vendor, it could be either in XML format or text data format or such. And so just depending upon who you are dealing with, you may have different requirements. So that's something is also missing within this whole context of how do you actually populate the RSU with the information or the message. So that needs to be carefully addressed also. Interface with the signal controller, and so broadcasting SPaT information that gets the information from the signal controller, and that is again matches with the map that has been defined and the lane level information that's been defined. So from a verification point of view, one needs to have a tool that can receive that information and compare against what was actually inputted from the step one and so forth. So the key that share my screen, okay. Oh, I lost connection.
I'm not sure. For some reason, the slides stopped sharing. I'm just loading it right now.
Okay.
Can you see it now?
I can see it my side.
Okay. It should be good.
Okay.
You can go.
All right.
We can see it as well.
All right. So what I was saying that the key element that we discovered during our testing and following through this process is that what is been interpreted by RSU from the information coming out from the SPaT controller and what is actually transmitted were two different things. And that is something very important element because your signal phase information is very critical for the application to behave correctly and don't give a false warning to the driver and or not give a warning to the driver, and it can be very unsafe. So this diagrams explains those steps and what are the elements that needs to be actually verified in this entirety. We'll quickly go over what are the attributes that are used for map and SPaT. And this is just a small list, but let me just jump into this list. This is where we talk about the SPaT data element. And if you notice, the 3 data elements are defined as optional in case of in the standards at J2735. However, those are required elements from the application's perspective, so application point of view. We also have experience with different installations that in some installations those are treated as optional and are not transmitted by the vendor, but from the application's point of view they are required data elements. Similarly for the map, as you can see, 6 data elements are defined as optional in the standards. However, from the application point of view, it is required to be transmitted. One of the element is called the lane level mapping for the intersection. Now, the application would have a very hard time to provide a correct warning to the driver if the lane level information is not transmitted. So that becomes a critical element, data element that needs to be received by the system. Just go over quickly on the couple of intersections that we have tested and what our findings were out of that. First, we found out that one of the intersections was transmitting information which was the 2015 version of it instead of 2016. We also learned that in one case, instead of transmitting the information about the current phase of the signal, it was transmitting information about the pedestrian crossing phase. So that was misinterpreted by the RSU vendor, and it was corrected. We also found that in the same intersection, from the map point of view, out of 4 lanes that are ingress to the intersection, only 2 were mapped. So when we drive our vehicle to the other 2 lanes, we never see any warning or anything coming up, primarily because those lanes were not mapped. But however, it was transmitting the part of the map. So these are the kind of anomalies that we discovered. We found a similar thing on another applications here that is transmitting 2016 version of it. However, the map was indicating that these are the egress lane and not ingress lane, which is what required for an application. So these are the little things, but they can really throw off the behavior of the applications. So that's what our observations were. And these are the kind of lessons learned we have identified in our document. I'll quickly go over the RTCM or positioning requirements that is a very important or critical element for the vehicle to know which lane it is on. And that is very important because a lane needs to be associated with the phase information for a specific warning related to that lane on which the vehicle is traveling. I'll go here. So there are several, the document identifies, and I'm not going to go over the detail about these things, but there are several errors that are generated from the satellite under different conditions. And primarily it boils down to what it says in this table is that depending upon what kind of error it is, the positioning error can be as much as plus minus 2.5 meters in some cases, and as low as 0.5 meter. So this table describes what are the different errors that can contribute into the positioning error, and the cumulative error could be much higher than 2.5 meters. So we talk about RTCM, and RTCM is one way to transmit those correction information which is standardized, and this section briefly goes over the RTCM part of it. So I'm going to jump to what are the different versions of RTCM is done. Now from applications point of view, we require that RTCM version 3.0 is used for transmitting this information. So again, by transmitting the different versions may have different implications on the receiver side of it and the positioning accuracy side of it, which can impact the behavior of applications. So what I'll go over it here. So the big question is that, do we need a RTCM correction for every intersection or everywhere we install the RSUs? Well, whatever our work, that research work that's done at camp as well as at other literature studies indicate that what we have done is identify those intersections in 3 different classes. One is, let's say you have an intersection that is an open sky, clear visibility satellite intersection. In this case, and your complexity of the intersection map and SPaT is not very complex, very straightforward, which may not have many turn pockets or just a straight line, and they are all very nicely laid out. In such case, even if you have a RTCM correction, the benefit that you get may not be does not add as much benefit to the positioning corrections in the vehicle side of it. On the other hand, if you were to go to an intersection such as in a downtown where the high-rise buildings are there and such, even if you add intersection with RTCM correction, if the vehicles are not able to see the GPS satellites, it cannot apply the correction, so it doesn't help either in such case. However, what we are recommending is that if an intersection is complex, even if you are with a clear sky visibility, but intersection is complex, which is a complex SPaT and map phase informations and position, that's where the position correction will be very helpful, because that will allow the application to behave as intended, and specifically to have a much better lane level accuracy, so the warning can be generated accordingly. So with that, what this table describes that benefits under different conditions that you can get when an intersection is equipped with a hardware, in which case you can have open sky conditions or obstructed view conditions. But under the open sky conditions, with the most complex intersection layout and the SPaT information, that configuration gets the most benefit with the RTCM correction. That's my talk and my presentation on this document that's been published, and it's at NOCO website. With that, I'd like to transfer it to Joe Gorman.
Thank you, Jay. My name is Joe Gorman. I work for the Michigan Department of Transportation in our ITS program office. My job specifically focuses on connected vehicles and building the foundational elements of a mature ITS program, so specs, details all these deployment policies and technical support for any type of deployment. As Jay mentioned, we did our first couple verifications with CAMP using their the more initial version of their document. So a lot of this I tried to make sure it wasn't too similar. So I'm going to kind of present what we've learned from leading up to the deployments that we could verify, and some things we learned during the deployments that may be, or during the verifications that may be helpful for other people as they are deploying and verifying. So there's three levels that you're verifying. You're verifying the system level, which is the communication between the RSU and the controller. The message level, which is kind of your over-the-air messages. These are the message sets that you need for your applications, and then the standards that define those and the elements within those, and the application level, which are the data elements of those applications, or of those messages that are needed for the applications. Really, as a infrastructure owner operator, we don't make vehicles. We're not, in there. We have partners that do those things. So, you'll have to work with your partners to really test or understand the application level. We did 3 types of intersections. The first 2 were with Jay. They were large 8-lane cross sections with divided medians, indirect lefts. And we recently tested one that we deployed for ITS America, and it's Jefferson Avenue, Detroit, from Griswold to Bobby, and there are 5 intersections on that corridor, and it is by far one of the most complex areas we probably could have tried. There's an international border crossing, a pedestrian mall, an underground parking area that's accessible through the median, so we did not do ourselves any favor in terms of simplicity to the test. So what we learned at the system level leading up to the deployment and the verification is that the communication that we're testing is between the signal controller and the RSU, but a lot of the communication that was necessary was between our signals unit and our ITS unit, which deploys the RSUs, and understanding how their business process works and how we can, establish a kind of joint business process to enable SPaT at intersections. Something we had to do was coordinate with them to ensure that our traffic controller specification moving forward supported the necessary elements to have a SPaT broadcast. So we did a little refresh to our signal specification to ensure that we wouldn't have to continue to procure special equipment or worry about this in the future as we go to deploy this. As a result of that, there was a policy that all traffic signals that were new or upgraded on the MDOT system would be enabled for CV applications. As Jay mentioned, and I think there was another webinar about this too, there's really no super standards. There's two standards, but they're implemented in different RSUs, and different signal control manufacturers may have a different output from the controller to the RSU, and that may be a factor in how things work. So it's a good place to start. Just talk to your vendors, understand what's going on. Most things are settling down now. It's a little less complicated than it was a few years ago, but it's still something to watch out for, especially if you have some slightly older hardware in the field that may have claimed to be SPaT enabled or something, and you purchase a new RSU to go out there. You're going to want to make sure everything matches up. We've also found that sometimes a little bit older hardware can be modified with a firmware update to support brand new SPaT applications, so you might not have to upgrade your hardware to support this. The coordinating with your traffic signal staff is very, very important if you guys aren't the same unit, or even if you are in a slightly divided unit. That a lot of stuff that as a primarily ITS engineer I do not understand about signals. As much as I wish this all was plug and play right now, it's not necessarily that simple. So understanding what's going on out there, what you can expect out of that controller, is a lot of things with the coordinated systems that they have. If you're not including all the optional data elements where you may be expecting a countdown and something will happen with detection and this, the phase will cut short and you think something's wrong with the broadcast because it knew it was what it said, but in reality, that's exactly what the system was supposed to be doing. You just weren't aware of it. So that coordination is very important. The message level verification, as Jay mentioned, I'm sure it's been hammered home many times by now. Looking for SE J2735 2016, the March version of that. For any over-the-air broadcast, everything should be encoded and formatted to those standards. What we learned on our intersections was that the version control, especially if you're over-the-air stuff, is very important, especially if you've deployed early hardware. We've got, a number of early deployments and test beds and stuff that are all using slightly different versions. As Jay mentioned, we even had some kind of, half upgraded some stuff in 2016, but using 15 data elements. So, we're working on getting, establishing some best practices of finding those older versions and making sure everything gets upgraded and making sure the controllers and everything can support that. So that'll solve a lot of problems from the desk before you get out in the field. The other one is understanding the level of accuracy you need for your maps and what messages you need in there, what individual data elements you need in there, and making sure everything's properly encoded based on the distance that you need, your approach distance. The encoding per the standard changes what format it is in depending on how long that approach is and the distance between the nodes. As Jay mentioned, the optional SPaT and map data elements that you may need if you're running a coordinated system, or depending on what application you want to support, you're going to want to make sure that everything that you need is there, even if it is optional. And that may involve talking to a RSU vendor or controller vendor to make sure that's actually in there, because you can support the standard with all the required elements and not the optional elements that may be critical for your application. You need to establish best practices for map data collection, especially when you're dealing with really complex intersections. It's fairly easy to understand your approach and egress lanes and the lane use and kind of the phase lane mapping for a fairly simple intersection. When you're getting into larger complex corridors with dedicated lanes that might not go all the way through the intersection, multiple signal heads, indirect left turns, tight intersection spacing, you're going to really want to look at how you're laying out your signal group IDs, what your intersection reference IDs are looking like. Per the standard, those are supposed to be kind of a unique reference with a regional and then a kind of unique sequential ID on there. That way, not only can you keep everything straight, but when you're out there testing, you have a really good idea of what you're looking at, because from any given location, you may be picking up more than one intersection, so you don't want to be saying, oh, this is all wrong, because you're looking at the next intersection down the road and it's not matching what's in front of you. Oh, looks like I may have lost some slides for some reason. Well, what was here was there was a nice 3 blocks. The top block was application level, and the bottom was a system and message, and these arrows kind of went from the application to the system level. But what I wanted to say with that was just that when you are defining your applications, that may come back to the supporting elements of the system and the message. So you may have to kind of work in a loop or an iterative process to understand that for one application, you may have the right data elements, but you may need to go through, and you might find in your verification that for another application you want to support, you may need to go back to the system and back to the message level to make sure that everything's supported. A good example is you can have signal phasing and timing out there, but if you want to do like a signal request or some kind of signal priority messaging, you may need to go all the way back to the system and make sure that the controller hardware can support that, and that you have an established application at the system level, even if the message and the application exist. Some other lessons we learned there, again, were the optional data elements must be included. So, talking to all your vendors for, all levels and any partners you may have that are building applications, or if you're working on building a specific application, really understanding what you need. Just saying that, oh yeah, it's in the standard really isn't enough, because there are a number of optional elements that are very important for a number of applications. When you're laying everything out, something we learned on the tight urban corridor spacing is that you may need long approaches and they may overlap, which is going to look very confusing to you, but it doesn't necessarily mean it's wrong. And that's again where those defining those ID elements is really important, so you can keep track of that and make sure that the vehicle can also keep track of that. Something we ran into also in these kind of tight areas is establishing a best practices for like messages along a corridor. You may want to split up your SPaT on one channel and your map on the other. There is no real standard for that. The FCC defines channel 172 as registered specifically for safety of life applications. So you see a lot of it's kind of de facto standard that you're broadcasting SPaT on that, but that's not necessarily any established standard anywhere, and that's the same for if you want to go in, you want to do a travel information message or something. It may vary, so kind of establishing what you're going to do in the area, so what people can expect. You'll have other vendors that you might not even know about driving around out there listening to your messages and saying, well, I was looking for this over here, where is it? And you say, oh, well, it's actually on 184. Did you look there? And they say, well, no, I wasn't expecting it. So it's easy to have that. If you have that catalog, or at least have a best practices document, it's easy to distribute. And then with that, just kind of understanding what's out there. You may have a number of people, as we do in the Southeast Michigan area, developing applications that may drive by. They know the test bed is out there or something, and they're looking to see what's available, and they're going to ask a lot of questions. And understanding exactly where you are from, SCAJ 2735 version support through, SCMS or any kind of security credentialing support, or, PSID supported. All that information is good to have, kind of in your back pocket, so you can keep it straight, and anyone else, driving by trying to use it can take a look at that. Just included some quick resources here. There's the SAE standard, the SEC actual rules in the Federal Register for or Code of Federal Regulations for channel allocation, and the link to the FCC Universal Licensing System if anyone needed that. And with that, I will turn it over to Chris.
Great, thank you. My name is Chris Stanley from Leidos, the Senior Director of Transportation Research and also the Program Manager for the Saxton Transportation Operations Lab. What I'd like to quickly do is walk you through the connected non-automated vehicle support services that FHWA is providing via the Saxton Lab for deployers, and hopefully as a research to answer a lot of the questions that arise from these presentations and then from deployment. We have a variety of support services that range from a help desk to testing configuration, and then some tools that have been developed to assist deployers. The website is cvcs@samanage.com, and we encourage everyone to open an account because that enables you to submit support requests, request hardware, report any bugs or issues, request features and equipment. And so if you don't have an account, when you go to the landing page down here at the bottom is a location where you can sign up, and typically we respond within a short period of time or the next day if it's an off time period. Once you have an account, then it brings you into the entrance of the site, and here you can place requests, you can find helpful information and request specific needs or changes that may relate to you. One element that I would like to share is that we're in the process of updating the web pages and the organization, so it will change in the future, but we didn't want to delay being able to share the information and the resources. Some of the support services we offer is device testing and configuration. We wrote the 4.1 specification, and we've tested several of the devices out there, and so we can provide some information or guidance for deployers. Support on installation, mounting it on mast arms, location, general information like that. We also have some frequently asked questions there, and then one of the areas that we'll be supplementing and strengthening in the future is going to be support documents and links. One of our most popular programs, and a little bit of the lesser known, is an equipment loan program, and this is great for those very new to this technology. Is we have equipment that we can loan out, that we can mail to you. So the roadside units, which are the DSRC radios, the onboard units that receive those messages. We have DSRC sniffers that can analyze the wireless communications to confirm they're working. We actually also have trailers that we've built with solar panels, some with generators, roadside units for field testing in different locations without actually having to mount equipment physically or permanently. And then in italics there is an item that we are looking at procuring or developing, and that would actually be a test device. A lot of jurisdictions have deployed radios. It says it's broadcasting MAP and SPaT. How do you verify that? You could use a DSRC or wireless communication sniffer or analyzer, but it's still very technical, and so the intent of the test device would be, in the image at the lower left, would be a tablet-based visual display where you could actually see your map message overlaid on an aerial photo and then see the signal phase and timing in real life, which I think would be a great way to verify you have it broadcasting SPaT map, but it can also confirm your phased lane assignment to make sure you have the right approaches illuminating at the right time. And then also just for, I guess, the political aspects of funding, which often jurisdictions, those elements are less technical. This can provide a very visual illustration of what the technology is able to do. And then we've also developed several tools at the link here of webapp2.connectedvcs.com, and there we have map message creation tool, which enables operators to develop the SAE J2735 2016 standardized map message and encodes it in GeoJSON or hexadecimal for loading onto RSUs or other roadside equipment for broadcast. And then we also have a comparable tool for developing a traveler information message that can be loaded, and then we have a message validator that enables you to take messages and insert them in here and then check the validity of them against different message types. For example, the map message, the SPaT message, the signal request message. And so the access is cvcs.semanage.com, or there's a phone number available there if anyone has any questions. The Semanage site is going to be the best way to reach out because that'll place a ticket that we are able to track and make sure that we follow up. But it also enables us to track interest in the areas that are most important to the user community, and we use those to go back to FHWA to make sure that there's support and funding for the areas that are most needed. And I guess I would also add that if there are other support services that deployers are needing that we're not providing, or different equipment that will help deployers, please enter those in there so we can do what we can to add those to make it as easy for everyone. Thank you.
Thank you, Chris. So I just, first of all, thank all the speakers. We had some great information here. Before I move on to the poll and our Q&A section of the webinar, just wanted to quickly remind everyone about the 2 upcoming webinars that are added to this series. There has been some great participation from you all along, and for that reason, 2 additional webinars were added, one on July 17 that will discuss the agencies that have operational deployments, and it'll highlight some lessons learned. So if you go to the SPaT Challenge website and register for these webinars, you can see that 1 question is added when you're registering. It is not required, but I encourage you to answer to that question, which asks you to, think about what are the questions that you want to ask from those agencies that are operational. Because as stated here, a good amount of that webinar would be dedicated to Q&A. So if you have any questions that is bugging your mind that you want to, use in practice for your agency, list those questions. If possible, just put it in the registration form so we have it in advance and we can share it with the presenters. If you don't have it at that time, you can later ask it during the webinar. Also on August 14th, same time as this webinar, we will be having some more application-based presentation for agencies who have gone beyond the SPaT challenge and deployed some different applications. And also we will be talking about agency fleet vehicles as part of the Connected Fleet Challenge. So let's see. I will bring up the pod here for polling for the poll questions. So we had 2 questions to ask you to get your feedback. One is, so I appreciate it if you type any questions. This is just an open question. Do you think there is a need for these webinars? Which, if yes, so what are the topics that you would like to be addressed? So we have a tentative agenda, but if there is something special that you think would be good to have, please feel free to type it here right now. I will wait like a minute for you to put your answers in for this poll. Thank you. And if you agree with the topics that we already suggested, you can type in agreed, not agreed, whatever you think. So I guess it wasn't open until now. My apologies, but it's open now, so you can type your answers. Okay, let me open up the other poll. Oh, I see more answers coming. So let's give it a little bit of time. And I'm broadcasting results so you can see them as they come. So I see 6 answers now. So the topics of interest are lessons learned, updates at a date to be determined. Another person says, yes, please include design examples, typical details, and specs. Somebody disagrees with additional webinars. We have a maybe for a future webinar in 6 months. We have lessons learned, so quarterly maybe. We have lessons learned on physical deployment and other best practices, and ongoing updates on developing tools and technologies. So thank you for those answers. For the sake of time, I will bring up the other poll I prepared here. So in terms of resources, is there a need for developing a new resource document to help your agency respond to the SPaT challenge? If yes, what are the topics that you would like to be addressed? And to make this more clear, you probably have already checked out the resources under the SPaT challenge page, and we have several documents, Q&A. We also have this webinar. So there are like documents, PDFs, there are webinars. So there are different formats and also different topics. So We were just wondering if there's like a combination of desired format and desired topic that you see a gap and you would like to be covered. I'll just wait a few seconds, and I realize that this is something that you may need to have some time to give some thought to, so feel free to email us later with any thoughts and feedback that you have. So I'm broadcasting the results. I see 2 answers. Yes, FCC application guidance and use of optional elements in the SPaT message like that are such as the likely time mark value. So the other feedback we got is that updates with the documents as the standards get updated. All right. Again, I appreciate everyone's feedback, and please let us know if you have any feedbacks for these 2 questions or just anything in general that can be helpful for our agency to deploy SPaT challenge. So let me end this pause and bring up Q&A. So while the presenters were doing their presentation, few questions came up and were answered. I will give the priority to the ones that are unanswered for now, and if time allows, I'll go back to the questions answered already in the text box. So I can see Chris already typing, so I'll just ask the question and have him here with audio answered. So Chris, can you give more of a description for your DSRC sniffer and your V2I test device? Are these basically software you use with an OBU, or are they off-the-shelf self-contained units as well?
Yeah, so the packet sniffer is a technical piece of hardware or equipment that requires software running on a computer to use. And that's part of the reason behind wanting a less technical, more user-friendly device that would be a tablet as an interface that would operate with an OBU or onboard unit DSRC radio.
Okay. And I see Charkful is asking you also about the loaner equipment. Do you have RSUs and OBUs from different vendors that can be loaned out? If yes, who are those vendors?
Yes, we do. I would have to check the inventory to identify which specific vendors we have at the time. If there's need for a particular vendor, we are periodically augmenting the inventory. All of the equipment we have is being updated for the 4.1 standard for the RSU and to support the 2016 J2735.
Okay, great. So Jim Rose asked us to share the CAM validation document link. I will share that with you later. So while folks are thinking of questions, to add here, let me go back quickly and ask the previous questions. So one question is from Steve, and others are welcome to add to that. So, Steve, who are we getting certificates from? Are there multiple options in the marketplace for us to use for SCMS? Up until recently, there were no options. Steve, you're on mute if you're talking.
I'm sorry. Yeah, so there is a Tampa and Alta CV pilots are using ISS as their SCMS provider. There are others that are trying to get into the market, eScript, Penta, and BlackBerry, and I have some contact information for those. If anyone's interested, they're welcome to reach out to me, and I'd be happy to try and help hook them up with anybody.
Thank you, Steve. I guess another question that is somewhat related is that OmniAir has only certified one CompSignia device so far. For those of us with 4.1 compliant devices, do we need to replace them, or can we certify them online?
Yeah, so, and I didn't say this one in my introduction, but I happen to be the chair of the OmniAir Consortium right now. And so what I would say is this: if your vendor has a device in the certification process right now or is going to be soon, what we've seen so far in terms of changes required is really going to be have been firmware changes. And so if you have devices deployed in the field and they get, once that single device gets certified by OmniAir, I believe you may just have to do a firmware update to get the device in compliance. If there is a hardware change, then yeah, you're going to have some issues in terms of you may have to pull the units down and have the hardware installed or swap them out with the new unit or something.
Thanks, Steve. Anybody has anything to add to that? Okay. I also see a question about issues accessing the CVCS website, but I think that is already responded to offline. Let's see, am I missing any questions? Apparently not. So I don't see anybody typing, and I don't see any more questions coming. Are there any last thoughts from the group? Anything you would like to add or just add to the discussion? Okay. So I guess the presentations were so perfect, no questions remained, and that is great. So we are right on time with seeing no more questions. I'll go ahead and just thank everyone, all the participants for attending, as well as our great presenters for contributing to this webinar and sharing their knowledge with us today. So like I mentioned in the beginning, this webinar is recorded, and that will be shared with you with the slides in a post-webinar email follow-up. On behalf of National Operations Center of Excellence and our presenters, thank you for joining us today, and have a great rest of your day.